Hi students, in this lesson we're going to talk about solubility. So the first thing that I want to show you is a demonstration, and notice I have some drink mix here. And when you think about the word drink mix, just think about Kool-Aid. So I want you to notice that the more drink mix that I add, the more concentrated the solution gets. But I'm going to continue adding and see what eventually happens. There comes a point at which the solution is said to be saturated. That is, that if I keep adding drink mix, it's not going to continue to dissolve. Any extra solute that I add will just sink to the bottom of the container. And so that's kind of what today's lesson is all about. So we're going to learn to identify the saturation level of different solutions on a solubility curve. And by the end of the lesson, you should be able to explain how to create a supersaturated solution of potassium chlorate in a written response. So there are two types of solutions that we just talked about. You're going to go ahead and put this in your notes. There's unsaturated solutions, and there's saturated solutions. So the first type of solution, which is an unsaturated solution, is a solution that has less solute than the solution can hold at that temperature. So what happened when you added more solute? So let's go back to that simulation to kind of make the connection to what we're talking about here. So if I remove all the solute here, at first the solution is unsaturated because if I continue to add more drink mix, notice that it continues to dissolve. And so then that's the unsaturated solution. Eventually, I'm going to get to a point where if I add more drink mix, it won't dissolve anymore. And that's when it gets to be saturated. So at that point, you see how it says saturated. At that point, when you add more solute, it just sinks to the bottom of the container. So that's what we're going to put in our notes here. So if you add more solute, solute dissolves. But once it's already saturated, the solute sinks. And so how can I push a solution to have more solute dissolve? Well, there's a couple of things that you can do. When it comes to solids, so for example, like the Kool-Aid being dissolved in a liquid, you can do one thing. You can increase the temperature. And so that makes sense to us because we learned that in order to get something to dissolve, the water or the solvent has to collide with the solute and then kind of break it apart. And so for a solid, when we heat up the temperature, then that makes the solute continue to stay broken apart. Now, when it comes to a gas, however, the situation is a little bit different. In that case, we want to decrease the temperature. And increase the pressure. So my example of that is soda. So soda is made of carbon dioxide gas, which is being dissolved into some sort of liquid, the liquid that you're drinking. Now, how do I make the soda stay fizzy instead of going flat? Well, one thing I want to do is I want to cool down the soda. And the reason why I do that is because whenever you cool down a gas, then the gas has less kinetic energy. So it's less able to escape out the top. You ever notice how sometimes like you open the soda and then you hear that psst sound? That's the gas escaping out the top. The other thing that you want to do is you want to increase the pressure. That's why the cap soda is so much more effective than the Coke soda, the can soda, because you can put the cap back on top and then you can maintain the pressure over it. And so basically if you maintain the pressure over the gas, then it squeezes the gas back into the liquid. So what about the last type of solution? The last type of solution is called a supersaturated solution. And in supersaturated solutions, you have more solute dissolved than can possibly be dissolved at that temperature. In order for you to find out how to make a supersaturated solution, you're going to watch the next video where this guy makes rock candy.